All right, guys, as requested, let's go through some more quadratic function examples. So the first one we're going to review is a graph because that'll give us the basic concepts without us having to do all the different mathematical functions on it, or mathematical operations. So if we're looking at this graph, we can see it's a parabola. We know our ends are headed up towards the heavens. Our vertex is our turning point. So we go to where our graph is turning around, and it's right down here. The x value of our vertex is 5, and the y value is 7, which means our vertex is 5, 7. The axis of symmetry is in the form x equal to h. Remember, h is the x-coordinate of our vertex. Our axis of symmetry is a line that goes through our vertex. It's a dashed line. And the x value was 5, so our axis of symmetry is our dashed line, x equal to 5. It's called the axis of symmetry because it is symmetric, it being the parabola on both sides. So for example, from the axis of symmetry, if I start here at y equal -5, count over 2 to the right, 2 to the left, I have 2 different points on my graph, and they are the same amount away from the axis of symmetry. That's another way to graph when you don't have the graph given to you. Our domain of our quadratic is always -infinity to +infinity. We can plug in any value we want and we can still get an answer. From the graph, this means that we get all of the x values to the negatives and to the positives. So for example, if we're looking towards -infinity, which is that way, we're hitting all of these x values. And it'll keep going and going and going to the left as our graph continues to go up and up and up. We get all of the positive values of x because we're going to the right. We're hitting all the positive x values as our graph continues to go up and up and up to the right. Or if you don't like that idea, just think that all your parabolas and quadratics have a domain of -infinity and +infinity. Our range are our y values. This time, we're not looking left and right, we're looking up and down. Remember, interval notation always minimum to maximum. So if we start at the bottom, we have our vertex, we said was 5, -7. Of course, I would drop a sign. Why wouldn't I drop a sign? Everybody does it at some point. Thank you for humoring me. And if you are going, I caught that at the very beginning, it frustrated me, I'm very, very sorry. Okay. So let's look at our range. We have our smallest y value, which is -7. And then we go up and 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 up. And it just keeps going and going and going. So our range is going to be -7 to infinity. Infinity always has parentheses. And because we actually have a point where y is equal to -7, we're going to use a bracket because that means that we can be -7. If we could not be -7 or we don't actually get to -7, we use a parenthesis. Okay. Our graph is opening up like a cup, not down like a frown. And if it is opening up like a cup, that means that our leading coefficient is positive because up like a cup or up like a smile. Like when you smile, your mouth goes up, the corner of your mouth goes up. You're all happy, you were positive. It's when you're down like a frown that you're negative. Here, because our vertex is the smallest part of our parabola, it is a minimum. This also goes with our leading coefficient being positive. Remember, leading coefficient is the number that starts off our parabola. Now, for increasing and decreasing, we read in the English language and most of the Romance languages from left to right. So I'm going to look at our graph from left to right. So we're going that way. If I follow my graph like it's a road or a roller coaster, I start by going down. If I am going down, that means that I am decreasing. And then I start turning around at my axis of symmetry that we said was x equal to 5. And I start going up. If my graph is going up, that means that I am increasing. So our graph has been cut in half. We're decreasing on half, we're increasing on the other half. When we're talking about increasing and decreasing intervals, we're worried about our x values. So here, if you imagine our negative infinity x values on the left and our positive infinity x values on the right, yes, I know there's a 15 there, but just humor me. That means that we are decreasing on the left-hand side, which is negative infinity to 5, and then we are increasing on the right-hand side, 5 to infinity. Everybody gets parentheses because infinities always get parentheses. The 5 is getting parentheses because we can't make up our mind whether we are increasing or decreasing at 5. We're doing both. So here we said we are increasing from 5 to infinity. We are decreasing from negative infinity to 5. And yes, those must be in that order because your interval notation is always smallest to largest.